Right, so this question comes from 9C. And in 9C, we're talking about exponential modeling. So the question, let's read through it. It says the price of a home in a town was 173,000 in 2013, but home prices are rising. Oops, misspelling here. Rising by 4% per year. And it asks us to find an exponential function of this form. So Q is equal to Q sub 0 times 1 plus R to the T power. And so it is telling us to find an exponential function. But let's take a step back and let's think about in chapter 9 what the difference is between a linear and an exponential function. Because you'll have problems that will say, is this a linear function? Is this an exponential function? Or maybe a few sentences. You're going to see like some sentences on an upcoming exam that says, um, determine which of these represents an exponential situation. Determine which of these represents a linear situation. So why do I know without even having that phrase in part A that this is exponential? And how I know it's exponential is by looking at this. This is a increasing or rising, and increasing are similar words in the English language to mean an increase over time. They're rising by 4% per year. It doesn't say it's this right here, this percentage. So it is that percentage that tells me it's an exponential. And it's in chapter 8 that tells us um, that if you have the same relative amount each year, that it is a characteristic of exponential growth. So the relative amount or the same percentage is that exponential growth versus if this had said, maybe it didn't say 4% per year, but it said $4,000 per year. That is when you'll notice 4,000, that is a constant, same absolute amount, a constant growth. So those are those keys that we're looking for. And I misspoke. I meant in chapter 8, where it said that determine the difference between a linear and exponential function. So, but in this section in 9C, we are dealing with exponential growth and we are given this problem and it tells us to find an exponential function in this form. So when you are asked to find an exponential function, and you'll have this on your formula sheet, you have to find two things. You have to fill in two things. And the first thing you need to fill in is Q sub 0. Q sub 0 is the initial or the starting amount. So we'll call this the initial. Whenever you have a variable with a subscript of 0, it's telling you it's the initial. Q means the final amount. And then we've got R, which is the rate, and we've got time. But if I'm creating a linear model, I want to fill in two of those variables. And the two variables I need to fill in are R and Q sub 0. You leave the Q and the T for the model. Now we'll talk about when I fill in T to find Q, but if we want the exponential model, we're going to leave everything besides the Q sub 0 and the R. So going into the problem to find Q sub 0, that is the starting price of the home in 2013. And that is 173,000. So I'm going to say, Q is equal to 173,000 times 1 plus, and then I have to fill in an R, and so the R is the rate. Now it also says in the problem that you're going to use a positive R for growth, and then you'll change it to negative R So this will be 1 minus if it was decreasing. But in this case, it's rising. So when it's rising, you use a positive R. So if it had said decreasing by 4%, you would say minus 4%. But in this case, rising. So we're going to say plus 4%, but I don't use it in percent form. I change it to a decimal. So I drop the decimal point, the percent sign, and move the decimal 2 places to the left. This right here is your model. So this is what you put in as the model when it asks you for a model. That's all you need to write in it. Now, when you want to find the average price of a home, let's say it said, now I know they ask for every year for the next 5 years. They have a table to fill in. But let's just say it said, find the average price of a home in 5 years. That would mean I would put in the number 5 in place of T. So this is the model itself, and then I'm using the model here to find the price of the home. So I want to find Q, so I'm finding Q, but I plug in the value for T. And so I'm going to write everything the same. The only thing I'm going to change is I'm going to change the T to 5. And so let's grab the calculator and let's put this in just as I see it on my screen here. So it's going to be 173,000. And I can do this all in one line. And I would do that. I wouldn't do it in pieces because you have to follow the order of operations. Since you have access to the calculator, let the calculator do the order of operations for you. If you do this in pieces, you have to do what's in the parentheses first, raise that to the exponent of 5, and then last multiply it by the 173,000. But if you put it all in like this, and then hit enter, you're going to get your value. And then this one says to round to the nearest dollar, so I want to round here. And so I would change, this is look 1 to the right, and since it's 5 or more, I change this up 1 to the number 1. So that the average price of the home in 5 years would be $210,481. So let's write that on our paper here. Now, to fill in the rest of the table that you're given, you change the value of T each time and plug it into your calculator. Now let me show you how you can easily do that on this calculator. If you enter it in one time, and let's say I want to find in 4 years, all I have to do is hit second and then the enter button down here. So let me show you what I did again. Second and then the enter button brings down the previous entry so that you don't have to retype it. And then you just arrow back and change this to a 4. And so this is the price in 4 years, $202,386 when I round. And you would do that for each one, and you fill in the rest of your table.